Okay, welcome back, Algebra 1 students from spring break. Let's get into now graphing quadratics in what's called intercept form. Intercept form is going to take the form here of f of x equals a times the quantity x minus p times the quantity x minus q. And p and q are your x-intercepts. So we want to start with that. P and q are x-intercepts. In other words, that's where it hits the x-axis, where y is equal to 0. They're your x-intercepts. Okay, and then another quality we'll want to have is this axis of symmetry. AOS for short. And again, that's a vertical line that's going to run through our vertex. And that's x equal to p plus q divided by 2. Remember when we were in standard form, we used x equals negative b over 2a. And now in this form, if we see a quadratic function in this form, we're going to use p plus q divided by 2. And then, of course, a coefficient we want to look at here as well. When a is greater than 0, in other words, it's positive, then the graph will open upward, the parabola. And if a is less than 0, our parabola will open downwards. In other words, if we have a negative out front, a negative a coefficient. Okay, so these are some of the major ideas we want to begin with. The P and Q are x-intercepts, in other words, where it hits the x-axis. Our axis of symmetry is x equal to p plus q divided by 2. In other words, that's the midpoint between the two, and again, it's a vertical line at that location. And then remember, if our a coefficient is greater than 0, if it's positive, it opens upwards, and if a is less than 0, it opens downwards. And again, that would be an x-axis reflection if it opens downwards. Okay. Okay, guys, let's look here then at an example problem that we're looking on. F of x equals negative the quantity x plus 1 times the quantity x minus 5. Okay, so the first thing we want to do is identify our p's and our q's. Okay. So remember, if we're looking at this form x minus p with something like x plus 1, well, really we're looking at it like this, x minus a minus 1, right? And that's what got us to positive 1 there, okay? Because remember, this negative is built into the formula. Okay, so x minus a minus 1, in other words, our p here is minus 1. And here the negative is just standard like we're used to, and so q must be 5. So in other words, those are our x-intercepts, and let's just go ahead and put those here on our graph. Label your axes. And we have an x-intercept here, a negative 1. And one here at positive 5. Okay, so we want to plot those first. We want to just go ahead and put in those x-intercepts here. And that location, again, would be negative 1, 0, and 5, 0 if we wrote those as points. Okay, and then what did we want to do? Well, we want to find that, what's called the AOS. P plus Q divided by 2. And that's, remember, x equal to, so P is negative 1 plus 5 divided by 2. Negative 1 plus 5 is 4. 4 divided by 2 is 2. So x equal to 2 should be our axis of symmetry. So I'm going to go ahead and put that in here. And notice it should be midway between RP and Q, and it is. Look, it's 3 units to the left of 5 and 3 units to the right of -1. Okay, once we have that x equal 2 value, we're actually going to find what the y value is. So we'll do f of 2, and we're going to plug it in here to our original equation for every x in the function. 2 plus 1 times 2 minus 5. So what did we do? Well, we took what x equaled here for our axis of symmetry, and now we're going to solve for the y value of the vertex here. So I plugged 2 in for every x, and let's solve for y. Well, let's simplify first. 2 plus 1 is 3, and I have that negative out front, and 2 minus 5 is -3. Okay, so then I'm going to multiply. -3 times -3 is +9. Okay, so what did I do? I took the x value of my axis of symmetry and I plugged it in for every x, and then I solved for y. So 2, 9. And let's change our scale here so I can fit it in here. One, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go ahead and put in my vertex. So our vertex is going to be at 2, 9. Okay, so we took whatever the x value is of our axis of symmetry here, and we plugged it in for every x to solve for the y value of our vertex, essentially. Okay, and then now it's just a matter of connect the dots. Okay, so now our parabola, notice it opens downward because we have a what kind of a coefficient? Well, a negative. Really, it's a -1 out front here, right? Okay, so that's what's causing it to open downwards instead of upwards. Okay, so, all right, now let's look for domain and range. So we graphed it, and what did we do? We started by plotting, well, finding the P and the Q. Those are x-intercepts. We added them together and divided by 2, and that gave us our axis of symmetry, that x equals 2. And then I took what x equal to 2 was, and I plugged it in for x, and I solved for the y value of the vertex. So my vertex is at 2, 9. And then I just connected the dots, and it opens downwards because I have a negative a coefficient. Okay, so I'm just going to erase a little bit. Okay, let's talk domain and range. Remember, domain are my x values. Well, what x values is it going to exist on? Well, it's the graph goes this way. As it goes down, it's going to continue to go to the left. And as it goes down this way, it's going to continue to go to the right. And it exists in the middle, so that's what you got it, all real numbers. All right, range. Now, what y values does it exist on? Well, notice it's going to come up here. It's going to increase up to our vertex, and then it's going to come down. So the highest point it gets to here is the vertex. So we have a maximum here at 2, 9. So our y values will never get above what? You got it, 9. Y is less than or equal to 9. Okay, so what do we want to do with these? We want to determine what the P and the Q are. And now one little side note, if you had, say, something like x times x minus 3, well, really what you have here with this x is x minus 0. Because you agree x minus 0 is just x, right? And x minus 3. So my P here would be 0, and my P here would be 3. So if you ever see x by itself there, well, then that means that your x-intercept is 0. Remember, these are where it hits the x-axis. So that point would be 0, 0, and 3, 0. And then, of course, I'd go through all my normal steps, which is you'd add the P plus Q and divide by 2, draw in the axis of symmetry, and then plug in that value to find the vertex. And then see if it confirms with what you know. Remember, if A is positive, it should open upwards, and if A is negative, it should open downwards. Okay, so I hope these videos help you get started on section 8.5. Thank you.